Welcome back to the Python Developer Bootcamp. In this episode, we're diving into the world of pip and third-party libraries. These tools are essential for any Python developer, especially when building real-world applications. Throughout this episode, we'll explore how to leverage the vast ecosystem of pre-built Python code available through the Python Package Index, or PyPI. We'll cover everything from installing packages to managing dependencies. Get ready to supercharge your Python projects and streamline your development workflow. Let's get started. Imagine having to write every single function and module for every project you undertake. That's where third-party libraries come in. These libraries are collections of pre-written code designed to solve specific tasks. Instead of reinventing the wheel, you can leverage these libraries to add functionality to your projects quickly and efficiently. Need to make web requests? Use the requests library. Working with data analysis? Pandas is your go-to. With thousands of libraries available on PyPI, the possibilities are endless. In this episode, we'll guide you through navigating this vast repository of code, installing libraries, and managing them effectively. The Python Package Index, or PyPI, is the official repository for third-party Python software. Think of it as a massive library filled with reusable code packages for various functionalities. From web frameworks like Django to data science libraries like NumPy, PyPI has it all. It's the heart of the Python packaging ecosystem, fostering global collaboration. Navigating PyPI is straightforward. The website features a search bar where you can enter keywords related to the functionality you're looking for. For example, searching for web scraping will return a list of packages designed for extracting data from websites. Each package listing on PyPI provides valuable information. This includes a description of the package's purpose, installation instructions, documentation, and often links to the package's source code repository. Before incorporating a package into your project, it's essential to review its documentation. This will provide insights into the package's API, usage examples, and any dependencies it might have. Understanding how to effectively search and evaluate packages on PyPI is crucial for leveraging the wealth of tools available in the Python ecosystem. Now that we're familiar with PyPI and its vast library of packages, let's talk about getting those packages onto your system. This is where pip comes in. Pip is the default package installer for Python. It downloads, installs, and manages third-party libraries. Pip interacts with PyPI, fetching packages and dependencies, then installs them into your Python environment. This ensures you have the correct versions for your projects. One of Pip's biggest advantages is its simplicity. With a few terminal commands, you can access a wealth of Python tools. Let's demonstrate how easy it is to install a package using pip. For this example, we'll install the requests library, a powerful tool for making HTTP requests in Python. Open your terminal or command prompt and type the following command pip install request. Pip will then connect to PyPI, locate the requests package, download it, and install it into your Python environment. You'll see progress bars and messages indicating the successful installation. That's it! You've successfully installed your first Python package. You can now import and utilize the requests library within your Python scripts to make web requests. While the basic pip install command is straightforward, pip offers several options to customize your installations. For instance, you can specify the version of a package you want to install using the == operator. Pip install requests == 2.26.0. This is particularly useful when working with projects that rely on specific versions of libraries. Pip also allows you to install packages from sources other than PyPI, such as from a local directory or a Git repository, providing flexibility in managing your project dependencies. Section 4. Managing package versions. Managing package versions is crucial, especially when working on multiple projects or collaborating with others. Different projects may require different versions of the same library. Installing conflicting versions globally can lead to compatibility issues. In the next section, we'll delve into a powerful tool that helps us manage these dependencies effectively, the requirements.txt file. This file serves as a snapshot of your project's dependencies, ensuring that you can recreate the same environment across different machines and share your project with others seamlessly. Stay tuned as we explore the world of dependency management with requirements.txt. Section 1. The importance of requirements.txt. In the world of Python development, especially when collaborating on projects or deploying applications, managing dependencies efficiently is crucial. This is where the requirements.txt file comes into play. Think of requirements.txt as a snapshot of all the third-party packages your project relies on, along with their specific versions. This simple text file acts as a blueprint, allowing others to quickly recreate the exact same Python environment on their machines. Without a requirements.txt file, you risk encountering compatibility issues, version conflicts, and frustrating debugging sessions. It ensures that everyone working on the project is on the same page, literally, in terms of the packages being used. Section 2. Creating a requirements.txt file. Creating a requirements.txt file is remarkably simple. Pip provides a straightforward command to generate this file, listing all the packages currently installed in your environment. Open your terminal or command prompt and navigate to your project directory. Then execute the following command: pip freeze. Requirements.txt. This command tells Pip to freeze the current state of your environment, capturing all installed packages and their versions. The + symbol redirects this output into a file named requirements.txt. You now have a requirements.txt file in your project directory, ready to be shared or used for environment replication. Section 3. Using requirements.txt for installation. Now that you have a requirements.txt file, let's see how to use it to install all the necessary packages into a new environment. This could be on a different machine, a virtual environment, or even for someone else working on the same project. With the requirements.txt file present in the project directory, simply execute the following command in your terminal: pip install requirements.txt. Pip will read the requirements.txt file, identify all the listed packages and their versions, and proceed to download and install them from PyPI. You'll see progress bars and messages as each package is successfully installed. Section 4. Best practices for requirements.txt. Follow these best practices for requirements.txt to streamline your workflow. Keep it updated to reflect project dependencies. Include it in version control to track changes. Use with virtual environments for isolated setups. These practices ensure consistent and manageable Python environments. What are virtual environments? Imagine working on multiple Python projects, each needing different library versions, or collaborating with a team with different setups. Virtual environments are indispensable. They isolate dependencies, ensuring project stability and preventing conflicts. Section 2. Creating and activating virtual environments. Use Python's venv module to create a virtual environment. Navigate to your project directory in the terminal. Execute the command python3 m venvid venv. This creates a directory with a fresh Python interpreter. The .venv directory holds your project-specific packages. Activate it with source. venv/bin/activate your terminal prompt will show the environment name. Packages installed now are isolated within this environment. Section 3. Working with virtual environments. Once your virtual environment is activated, you can use pip to install packages just like you normally would. For example, pip install requests. All installed packages will reside within the virtual environment's directory structure, keeping them separate from your global Python installation. This ensures that your project's dependencies are self-contained and portable. To deactivate the virtual environment and return to your global Python installation, simply use the deactivate command. Deactivate Section 4, Virtual Environments and Requirements.txt. The true power of virtual environments shines when combined with requirements.txt. After activating your virtual environment, install your project's dependencies using pip install requirements.txt. Pip installs all the packages listed in the requirements.txt file within the virtual environment. Now, anyone who wants to work on your project can simply create a new virtual environment and run the same command. Pip will automatically install all the necessary packages, ensuring a consistent and reproducible development environment. Virtual environments, in conjunction with requirements.txt, are indispensable tools for managing project dependencies effectively. Section 1. Upgrading packages with pip. As you work with different libraries, you'll find that developers release newer versions with enhanced features, bug fixes, and performance improvements. Keeping your packages up to date is essential for a smooth development experience. Fortunately, pip makes upgrading packages a breeze. To upgrade a package to its latest version, use the following command: pip install, upgrade, replace with the name of the package you want to upgrade. For example, to upgrade the request library, you would run pip install. Upgrade request pip will then fetch the latest version of the request library from PyPI and install it, replacing the older version in your environment. Section 2. Uninstalling packages. There are times when you no longer need a particular package in your project. Removing unnecessary packages helps keep your development environment clean and organized. Uninstalling packages with pip is just as straightforward as installing them. Use the following command: pip uninstall, replace with the name of the package you want to remove. For instance, pip uninstall requests. Pip will then remove the specified package from your environment. You'll see messages confirming the uninstallation process. Remember, it's always a good practice to review your project's dependencies and remove any unused packages. Section 1. The power of pip and PyPI. In this episode, we've explored the essential tools of pip, PyPI, and virtual environments. These tools are indispensable for any Python developer looking to build real-world applications. With pip, you can tap into the vast ecosystem of third-party libraries on PyPI, adding powerful functionalities to your projects with ease. By understanding how to manage dependencies with requirements.txt and isolate project environments with virtual environments, you gain control over your code base, ensuring stability and reproducibility. As you continue your Python journey, remember to leverage these tools effectively. They are the foundation for building robust, maintainable, and